Camera pro, Ross Trethewey, ladies and gentlemen.
Trethewey.
What did I say?
Trethewey.
Yeah.
Trethewey.
I said it's Trethewey?
Trethewey, yeah.
Ross Trethewey. Jeez, it's hard to say.
It is a hard one, yeah, I know.
Yeah,
Rhymes with chop suey. That's the trick. That's why I changed the name of the company.
That's right. TE2 Engineering in Boston. And there are a bunch of things that I want to talk with you about. So this might be multiple videos, but number one, you're explaining this stuff to normal people like we do on this channel through this old house, right? You're their kind of resident engineering expert.
That's right. Yep.
And what you've been doing at your company is doing both commercial and also residential?
That's right.
Okay.
Yep.
It seems like two very different things to me. And so I often am interacting with mechanical engineers who don't know much about residential.
That's right.
Can you please explain to all of us why they're not teaching this stuff in mechanical engineering school? Why it seems like I feel like I'm off in this weird little niche making up stuff and there's not standards for this. Like ASHRAE doesn't know a whole lot about residential either. So can you kind of like give us what the landscape of where a mechanical engineer's mind is normally and then how to tease out the things we need from them like you do?
Yeah, all right. So to start off, when you're a mechanical engineer at school and you're trying to get your degree, all of that is focused primarily on theory. And the theory is very much based on industrial, commercial buildings and systems. So we talk about thermodynamics, when we talk about physics, when we talk about all that kind of stuff, it really is about you have this industrial plant that needs heating, cooling, whatever the thermodynamic processes are that we're examining, or heat transfer, but it's all going to be at a very, very large scale. You have, the traditional mechanical engineering route, you come out of school, you have a really good theory, like background, but you don't have a lot in the practical sense. And so like many disciplines, like many kind of industries, my hope is that in most cases, people will have some sort of like co-op or internship to be able to get some practical experience. So when you come out of school, you actually have practical feelings and understanding of how these things go together. In a lot of cases, you might have really good theory and understanding of the fundamentals, which is critical, but you don't have the practical sense in terms of how the building blocks and pieces go together. And so I think where you really get to become a really good engineer is when you understand the theory and you understand the practical side of it, and you put those two together, especially when it comes to controls and how the systems talk to one another. That's really the kind of the holy grail from my perspective. Now, to answer your question about commercial versus residential, the typical pathway is you come out of school and you go into a large MEP consulting engineering firm that's focused on commercial buildings. Commercial buildings, in many cases, need to have an engineer. It's required by the state, or at least in most states, to be professionally engineered, stamped, and needs to be designed.
And in fact, now I got somebody in California in a particular municipality that I don't think I had designed for that municipality before. And they told my client that they have to have an engineer's stamp on the residential plans, which that was the first time I ever heard that. So you might hear that from your local code official as well. Do you guys hear that around here?
Yeah, so if the building is over a certain square footage and size.
Which is what?
So in Massachusetts, it's 12,000 square feet. If you go above 12,000 square feet.
It's a commercial building.
They're thinking of that house as a commercial building and they want a PE stamp.
You hear that? So don't do that.
Well, that's Massachusetts. Every state's different. But in general, if it's a large house, like extremely large house, it needs to be stamped. Yeah. But the other thing too that's very critical here is that commercial systems and residential systems are very different. Very different. So you could have the best commercial engineer that understands VAV boxes, understands rooftop units, understands demand control ventilation, understands all that kind of stuff. But when it comes to residential systems, you don't have the same tools in the toolkit. So you have to use different tools, and it's a very, almost very foreign to most of the commercial engineers because they're not thinking in terms of condensers outside and line set lengths and air source heat pumps and hyperheats and those kind of products. They're not thinking about that. They're thinking about a large rooftop unit like we have on this building here with large VAV boxes and large airflows, large ventilation systems, and a lot of times all backnet controlled. It's apples and oranges. It's like almost like a completely different language.
Probably also, I mean, it seems like engineers, do they teach you to do a 300% error margin just to make sure that it's not, like, I know on bridges for structural engineers, that's what they do. They're like, okay, here's what the load is. We're going to do 3 times that strong just to make sure.
No.
I have heard, though, that people are just so averse to having their client call them if they, like, are doing a school,
Mm-hmm.
and you do a parent-teacher conference, and you have all the parents in one
Right.
classroom.
Right.
I don't want them to call me the next day,
Right.
so I'm going to go ahead and whatever it is, I'm going to double it.
Right.
Have you, as a not you, but as a standard of practice,
Yeah.
do you think that that's likely?
I've heard load calculations that are being done with a maximum occupancy in every single room all at the same time.
Yeah. Right.
Yep, I've heard that.
Okay.
Yeah. So that conference room is fully maxed out. The next conference room is fully maxed out. The auditorium is fully maxed out. I mean, they're maxing out everything so that they have the peak loads for every single room, and they're sizing everything based on that peak load. That is common.
Fine point here. I heard there's an ASHRAE heat load calculation. I can't remember what it's called, but it's based on kind of the balance. Heat balance
method, yeah.
I don't think that it's actually heat balance, but they were saying that the software assumes that there's not spikes, that the design, whatever the design is, was that for the last 24 hours straight. So there's no, like, in the case of residential, we're talking about going up to 5 p.m. as the, like, right now with the sun beaming in through the windows, stuff like that. Do you know anything about that?
I don't.
Okay.
Yeah, I'm not sure. I just know that, so ASHRAE has the CLTD method. They've got there's an RTS method.
I think it was RTS.
Yeah, it's radiant time series.
Yeah.
Yep, and then there's heat balance method. They all have pros. They all have cons.
Yeah. Okay.
Right, so there's no magic solution there, but there is part of it that the standard load calculations do not take into account radiant, and RTS method tries to take into account some of the radiant, meaning the time delay. There's a transient. You heat the room up, it takes time for it to actually heat up.
And like thermal mass.
And thermal mass, and then there's so basically there's different load calculations. Softwares and calculation methods.
Yeah.
RTS is one, to me, that's probably the best for commercial buildings.
Okay. And even in residential, which Manual J is like the right way to do them in residential, it's an art because that's wrong too. Like the heat is wildly oversized for buildings like you and I are building.
That's right. Yeah, so I think Manual J is great. It's a great starting point, but my viewpoint on it is that there's definitely room for improvement there. The question that I always have, and this goes back to ACA and some of the other people that are much smarter than me, is trying to figure out how many inputs do you actually need to actually get the level of accuracy to the point where we're happy with it. So like if you're plus or minus 10%, is that good enough with the inputs that we have? Or if we triple the amount of inputs, do we now get to a 2% accuracy plus or minus? But is it worth it to get triple the amount of inputs? That means that the time to do every single Manual J is going to be increased. Then the margin for error goes up with every single one of those inputs. So there's all these different trade-offs. And the biggest one for me is air leakage. That's the one that I see when I do a Manual J and look at it. The one that swings one way or the other in such a big way is how much air infiltration does the house have.
And this would be one way the commercial engineers and residential engineers and non-engineers, like I'm not an engineer, just to remind everybody, are totally different. Commercial, you don't even care about the enclosure, right? That much. I mean, it's like you're mostly designing for people and interior processes and interior heat loads.
Correct. Yep. But if you think about a commercial building, the commercial building loads breakdown is very different than residential. So occupancy is usually one of the biggest drivers for loads. Ventilation is one of the biggest drivers for loads because ventilation in commercial buildings is much higher than residential buildings. So if you look at a typical house, it might be 100 CFM of ventilation rate is what we need. If you look at a commercial building, if it was the same size as a house, it might be triple that. It may be even 5 to 10 times that. Right, like some of these commercial kitchens need 8 air changes per hour, right? 10 air changes per hour in some cases. Smoking lounges are very different than a cafeteria, right? So all of these types of use and occupancy cases have a CFM per person and a CFM per square foot, and this is all part of the International Mechanical Code. So if you go commercial, you follow the IMC. Yep. If you're going residential, you're following the IRC in most states.
And this is something where I've had a couple clients now come to me after getting with their mechanical engineer, and they've been watching the channel and they've learned all the kind of ins and outs of residential, and then they get this number that's like, I need 32 tons for this wedding hall, for example. I've got 2 different projects. One is like a wedding event space, and one is a daycare. That's basically a house. It's like a great big house, but each room is a classroom, and they have to have 2,000, they have to replace all the air in each of the classrooms 3 times per hour if they're going to meet ASHRAE code, which then means it's in Austin, Texas, they have to then introduce a whole ton of, not a literal ton, but like lots and lots and lots of air conditioning just to meet the need now of that ventilation.
That's right.
Is there any way around, like, is that just what we have to do?
Yeah, so what ASHRAE did is they came up with these tables that's based on what's your occupancy type? Is it a cafeteria? Is it a daycare? What is it? And when you look at that, it's a CFM per person and a CFM per square foot kind of multiplier. So if you know your occupancy type, you know your CFM per person, you know your CFM per square foot, you can figure out what that calculation is in terms of, let's say it's 2,000 CFM is what you need in that space. The system needs to be designed for that 2,000 CFM. That's just what, if you're following that code in that state and it is adopted ASHRAE 62.1, which most of the IMCs have, that means you have to meet that. But the way that we get around it is we put in demand control ventilation, DCV technology. So what we do is we'll put in, let's say, a CO2 sensor, and we'll say, if the building is unoccupied or if nobody's there, maybe we ramp that 2,000 CFM ERV down to, maybe we can get down to 200 CFM or 250 CFM. So the majority of the time it's running at 250, 300, whatever the low end turn down is for the ERV is. And then we ramp up only when the CO2 is present in the space, meaning that it's occupied. We could do it other ways too. So CO2 is not kind of the end all be all. We have some kind of, I have a love hate strategy for CO2, but in general, the DCV with CO2 in commercial spaces ends up being, I think, a really good one for the energy efficiency of the space. Because we could overventilate 2,000 all the time, but their heating and cooling bills would be.
And what I think is really interesting about this is that what Ross is describing is a long-term strategy for reducing your energy costs, for improving the durability of your equipment, like lifespan of the equipment. But it doesn't have anything to do with the sizing, the upfront sizing. You still have to install, which is what we've been talking about a lot on our channel lately, is like, how do we get that piece of equipment that I put in there to be the most modestly, perfectly tailored size that it can be? And in that case, we got to install 20 tons of air conditioning or 32 tons or whatever it is, because at that peak moment, you got to have enough firepower. Now, here's a question. Is that ASHRAE standard, is that filtration credited like the new ASHRAE 62.2 is? It is. Where like if we're doing HEPA filtration, we can get a bit credit?
So most states have adopted the 62.1. I forget the year, and there is no filtration credit for that. It depends on what version you're in. Yeah. But most states you don't get well, there's an infiltration credit. But are you talking about infiltration credit?
No. If you have a blower test, but now 2019 62.2, which I'll have a video coming soon about the new 2019.
Yeah, but most of them are 2016 or 2013 or 2012. I forget the exact years, but so some of them allow an infiltration credit. Yeah. And the new ones allow a filtration credit.
If you have blower test, which you guys do.
We do.
You do your own blower testing.
We do.
Nice.
We do.
Okay, cool. So, I mean, if you could find a rock star in your local area, great. For everyone else, which is, I think, 99.99% of people.
Yeah. But let me also add that there aren't many residential mechanical engineers in the space, period. And part of that is because there isn't as much in the budget for most residential projects to be able to hire a residential engineer to work on it. And so there's going to be various price points depending on how involved we are in a project. And so the path of least resistance for most engineers is just go to the commercial buildings because they're larger budgets, they're larger sizes, and they're required by code to have a mechanical engineer on it. That's not required in most cases residentially, and the budgets are a lot smaller, the systems are a lot smaller, and so it's not the path of least resistance, right? Yeah. For sure.
Yeah. Understood. Okay, so if we wanted to be able to get, it sounds like that kind of blower door test is an entree into the next big conversation that I just wanted to have to kind of finish this out, and then we'll talk about more specific things with plans that Ross has printed out here.
Sure.
But how do we tease out that kind of what you call the TLC for the residential space for dealing with these 5 factors, which again are circulation, capture and filtration, humidity control, dilution, air pressure relief, which maybe a mechanical engineer isn't thinking about in commercial spaces as much because it's kind of a given. Blower door test, we got to subcontract that out to a blower door tester because you're running your own, but that's not everybody.
Right.
So what else can we do to try and, if we have to work with a mechanical engineer who mostly works in commercial, how can we try and give them any crash course in what we're trying to get out of them to give us more of a design that you would produce?
Yeah, so I think, well, first off, like one of the things that separates us, I think, from a lot of engineering firms is that we have a client questionnaire and we have an architect or builder questionnaire.
Cool.
And so this is required on every project that we work on. And the idea is that back to the kind of the TLC, like when you're doing engineering design, especially residential, it's not so much black or white in terms of code. You really need to find that gray area where you're understanding kind of the balance point of all these systems to work for the building and the occupants of the building, but also doing it in a smart, strategic way without going overkill. And so the kind of what we think about our business is like, if it were our house, what would we do, right? So that TLC kind of concept is what we're trying to instill with our projects that we work on and stuff like that. And some of that comes from the questionnaire. As an example, what are the temperatures that you like to be at and what do you like to sleep at, right?
Ooh, I actually don't like that question very much because I think people base it on their last house or the one that they live in now, which is maybe not nearly as high performance as this one. Do you take that and like take it with a grain of salt and be like, okay, you're going to change your mind when you see this next time?
No, so it's a data point, right? And it helps us. And sometimes it will open up a conversation to say, you said 66 in your,
that's a red flag for me.
Exactly. So if you see that, though, at least you can ask the question and say, let's dive into that. Why did they say 66? Yeah. Right? We can have a conversation about it. Some people say, hey, I want to be at 70 degrees or 75 degrees during the day. Usually 70, 75 is what most people put for their temperature set points, but they might put, we like to sleep at 66 or we like to sleep at 64 or something colder and sleeping. But at least we understand we can run the manual J now in different scenarios. We can say, all right, let's look at the primary bedroom suite being, let's zero solar gain. Let's say they're sleeping at night. Let's see, can the system hit that 66 degree set point and see, does the system work for that or not? So we can put it in different scenarios to see, are we going to hit that comfort setting that they're looking for?
And FYI, I think most people would find, and I don't know if you would agree, that you can with the proper sized equipment because at 5 o'clock is what we're designing for. At night, the sun's not shining, so you've got lots of extra air conditioning.
That's right. In most cases, the solar gain is a huge part of the pie. So you take out the solar gain, you can meet it. And so only in these weird, unique circumstances have we ever had an issue where we couldn't meet it. But in most cases, it's not a problem. But it's good to have those kind of things. Are you a windows open as much as possible or air conditioning all the time for that type of person? We're trying to figure out how they're going to live in this house. Their bathroom exhaust. They want control over it. Do they want it automatic? Are they going to be cooking a lot? Are they going to be entertaining a lot? How many people? If so, if you're going to be entertaining, is there anybody that has respiratory ailments or chemical sensitivity syndrome? Are you interested in remote monitoring for your heating and cooling system?
Okay, so here's my wonder about all of this. My clients come to me from our YouTube channel.
Yep.
And so they are incredibly well educated already. Yeah. They already know what the answer to these questions are. They know that I'm going to ask these questions and they know what their answer is already. Mm-hmm. When you give this to somebody who's working with a fancy builder who is then bringing you in without their particular, do they select you or does the builder select you?
So most cases we're brought onto the project to the architect.
Okay, yeah. So the client doesn't necessarily.
No, they see this.
Yeah, but I mean, they might be like, well, what does that mean? Automatic bath exhaust.
Yeah, so what they do is they'll fill this out to the best of their ability, and then anything that they have questions on, we'll hop on a Zoom call with.
Cool.
And we'll go through it with them. So they'll say, I didn't know what you meant by, whatever the question is, right? And
that
what
sounds
do you mean by
kind of
that?
exhausting that you have to give them the crash course in home performance.
We do.
In the intro phase.
We do, yep. And the thing is, a lot of our clients a lot of the residential projects we work on are high-end residential projects. So they are bigger, they have larger budgets. They usually have fancy architects and fancy builders that are working on those projects. And so we're the ones that are trying to be kind of like the pragmatists and just say like, hey, we're going to design the systems of your building. It's important to get these questions and get it right. So we have an understanding of what's the definition of success for them. Because everybody has a different definition of success in terms of what they think is a great project. I think of like acoustical noise. I think of vibrations. I think of controls. I think of those things as those ones that can really sway the project one way or the other. We're going to get that right as well, but we got to get the basic blocking and tackling right, and then we can get into all the cool stuff and the nuanced stuff to get it right for that client.
On the other end, have you had people who are maybe chemically sensitive or EMF sensitive that pick you and then say, Ross, I want you to get me an architect who can build me a house that is that?
I'm trying to think if we've ever had it go that way. I can't think of one case where we were asked first. I think that may change in the future, but we don't market as well as we probably should. And that's one of the things that's kind of fallen kind of through the cracks, you know. And hopefully,
I think that's amazing. Most people would die to be on a television program that's as big. This old house, by the way, is as old as I am. It's 45 years old. And so you're on television and you're saying that you don't market well enough. I think most people are well, all I need to do is, so it's refreshing to hear you say that.
Yeah, I mean, obviously I'm on the television show and that's great. And that is marketing for sure, no question. And I'm very fortunate and lucky to be on the show, no question. But I'm saying for marketing for TE2 Engineering, for our consulting business, we basically do almost nothing. for that. And so if we really wanted to scale our business up, which obviously is on the roadmap, we would definitely need to market better. We need to bring on more people. We're at like, 12 people right now. So we need to ratchet up with more resources, more people, more marketing, and be able to kind of cater to all the different clients. Especially, we're getting inbound requests for different parts around the country. And it's, it is daunting to be like, all right, do we have enough bandwidth to work on that project with that XYZ client and get them up to speed and do it with the TLC that the project deserves, right? Because the last thing I want to do is sacrifice quality.
It takes more, yeah.
Yeah, exactly.
Absolutely.
So it's definitely a balancing act for sure. And that's, it's a good challenge to have, don't get me wrong. But yeah, that starts with the questionnaires. Great. Definitely, this is 3 pages.
Can I share this with everybody?
Sure.
These questionnaires?
Yeah.
Okay, great.
Yeah. And then the architect builder questionnaire is another one. So this is talking about the gas, is there a gas kitchen range? Are there any floodplain concerns or zoning issues? What's the solar heat gain coefficient for the windows, peak occupancy of the building, lighting loads, anything that we should be aware of, typical appliances, any other general notes or any concerns that they have. So basically with this information, with that information, we've got a lot of our general questions answered, so we can kind of then let loose, run the manual J, get into load calcs, and start the design process.
I think this is one moment. So like once they've done all that and you've asked them what you asked them, what is the peak load of occupancy? Because I do not have employees and my clients are who they are, get to say, what is that, and then data point. And then I'm like, okay, don't do that.
Right.
Please.
Right.
Let's do this instead. Don't have a party at 5 o'clock in the afternoon on the hottest day of the year.
Right.
Okay.
Well, yeah.
And then we can do this.
We have clients that fill that out and they write 100. And I'm like, I know it might be a 12,000 square foot house, but I'm like 100 people.
So do you push back?
But it's a conversation. It's a conversation to be like, are you really saying 100, or are you just really because you're concerned about the sizing of the systems? You really want to make sure everything's ramped up. And so it's a conversation to say, look, if you have 4 people in this house or 5 people in this house, the majority of the time, we should be designing for that. The 4th of July crazy party that you might be having, or some graduation party that you might be having, yes, that may happen. We're not going to design the systems for that. That doesn't make sense.
This is where your questions of the specific question that I got from a very cool guy who was like, I want to know from you, am I doing anything stupid? I mean, aside from just building this house the way that is, I know it's too big, but point out to me where I'm going wrong. And I think that's a really useful ask, because Ross doesn't want to look like a jerk by coming out and being like, hey, I think that you're doing this wrong.
It's a touchy subject. It's definitely, and you got to it comes with experience of how to approach those conversations and how to say it without coming off as being an asshole, So it's like you want to make sure that you're doing it in the right way. But it definitely, it's a tricky one for sure.
Okay, yeah. Awesome.
Yeah,
so,
am I allowed to swear?
Of course you're aware. Yes, this is not a family channel. This is a science channel. We're pursuing the excellence of science. All right, so we're going to get into some more specific stuff here in a minute with Ross. But for right now, just remember to ask the right questions, including what are we doing wrong. Make sure that you have people asking you questions, that you don't just say, hey, I want you to do this, and then they are like, great, here it is. Like, we didn't have a conversation at all. That talking and emailing back and forth and data points is very important.
Yeah.
Do comment below if you have anything to add about mechanical engineering, or if you are a mechanical engineer, you want to add your 2 cents, that'd be great.
Yeah.
Check out Ross's company. I'm linking in the description below as well. Like, subscribe, tune in next time.